I'm going to do a quick review of a Schneider soldering station from Harbor Freight and put it through its paces just a little bit and see if it's any good. It seems to represent a pretty good deal at only $45, and I think some people have reported that they used points or a special deal and got another few bucks off. Anyway, I did open it up and look inside of it, and it is a proper temperature adjustable, temperature censoring, sorry, can't speak today, temperature sensing soldering station with a proper circuit board. I will show you that at the end of the video. When you turn it on, it confuses people because the LED comes on solid, and it takes about 25 seconds or so to get up to 700 degrees Fahrenheit, which is a good soldering temperature. It'll start blinking then. There you go. That's up to temperature. If you turn it up or down, it'll go solid, and then it'll go to blinking again. Actually, if you turn it down, the LED will go out while the temperature drops, and then it starts to blink again. Obviously, a little bit of metal mass there, and it takes a few seconds to go back down to the temperature you set it at. Anyway, we'll put it back up to 700. Okay, very quickly made an adjustment between 6 and 7 because you have thermal mass of the tip that's going to hold heat. Now, a word about the tips. The 3 tips supplied are conical and pointy. As you can see here, not much difference between them other than a little bit of difference in length. The problem is they're not made of the ideal material. Obviously, they're made of iron or steel and are heavily magnetic. Good quality tips will be made of copper because copper is a better transmitter and conductor of heat by far than steel or iron. And then usually they will be plated with something like chrome that resists solder. If you try to put solder on the upper part of the iron here, it will just ball off, which I will show you afterwards. But anyway, all of these tips, instead of being copper, are steel throughout. Even the back end is strongly magnetic. Okay. If I use a better tip that's made of plated copper, virtually no attraction. Another couple of tips, minor attraction, okay, to that one. But where they really are attracted to the magnet is at the tip. And there's a specific reason for this. Quality tips are made of copper, yes. The upper part of the tip, the back end of the tip, is plated with something that resists copper, maybe chromium. But the very tips are supposed to be plated with iron. And the reason for this is that iron, while it will allow solder to wet to it, will not be easily dissolved or alloyed with the solder, and so the tips last much longer. If you use plain copper tips, they will wear away very quickly. They'll oxidize, they'll pit, and the lifespan will be very short, perhaps in the space of minutes or, a half hour, no matter how much you try to clean them. And you can't file them, shouldn't try to file them, because if they do have any kind of plating on them, you will remove the plating, get down to the base metal, and if it's copper, it'll oxidize quickly. If it's iron or steel, it may not even accept solder well and wet to it without that, 'that, that, 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 base plating that was done at the tip. Anyway, I did try doing a little bit of soldering with one of these supplied conical tips that came from Harbor Freight with the Schneider iron. But it worked okay. But I switched over to a copper tip because that has greater thermal efficiency and it should transfer heat much quicker. Plus, I don't really like the conical tips like these, same, that come with the soldering iron. I would strongly suggest you buy other tips elsewhere and don't just buy them from Amazon, Alibaba, Fleabay, Temu, or whatever. Buy them from a good electronics distributor and somebody that will easily refund your money if you don't like them. When you buy tips, check them with a magnet. If they're magnetic at the back end, they probably won't give you maximum heat transfer, and you may struggle with some soldering operations. Also, of course, I prefer a rounded chisel tip like this here, sort of a blunt chisel. And you can get them in different tip sizes and widths, but I find them more efficient. Here's a conical tip, but at least this one is apparently copper and not steel. Okay, so let's see how well this thing works. Oh, the stand. The stand is okay. It kind of slides around a bit. It could use some rubber or felt or something on the bottom of it so it's not quite as slippery. And it's mostly plastic, which isn't ideal. It does have a metal shroud in here, so if the iron touches it, it won't melt and it won't foul the tip, because plastic melting on the tip is generally pretty bad for it. It will cause you to have to keep cleaning it, and you might need the special tip cleaner, which is very alkaline and harsh, to get traces of melted hydrocarbon from plastic off of the tip. Okay, but it comes with it. It will work. Like I said, it's plastic. Is it heat resistant? Seems to be. This part actually is metal. This is metal. The rest of it is plastic. Now let's check the cord. The cord is thick and pretty stiff, unfortunately. I don't know how good it is for here, let's find out. I don't know if it resists heat. Let's find out. It does not. It will melt. Hit it with the iron and see the smoke? Okay, so I've already put a divot in the cable. Better quality irons will typically come with silicone cable that is heat resistant, and you should be able to hit it with the soldering iron without melting it. So I might actually replace the cable on this if I have sufficient cable. The connector is very high quality. It's a surprisingly good 7-pin with a metal shell, much better than the plastic molded DIN plug that is seen on many irons. Okay, should dissipate heat better and probably last longer. And you can get inside of it and remove it or change the connections or whatever. So I don't know how many of the 7 pins are actually used for heat and temperature, probably at least 3 or 4. But I should be able to replace the cable if I need to. It's not something you're going to get from Harbor Freight, I'm sure. And when I looked around online, I did not see these particular irons being sold separately by Harbor Freight or anyone else. They have a parts list in the manual, in the lousy manual that comes with it, but it's not clear whether you can order parts from them, and they don't show the iron as one complete part. It's only shown in the manual as individual components, including the heating element, the handle, so on and so forth. So while it would be nice to order a spare iron for it, it doesn't look like they're going to make it easy unless someone else out there has a compatible iron that will plug into that same connector or can be adjusted. So let's kick her back on. I'll take the cover off and show you the driver board later. And we'll do a little bit of soldering and playing with it. I did buy their accessory kit, including a plunger type solder remover, which makes a little vacuum and sucks the solder up in the end. The tip is Teflon or some similar, high temperature plastic, reasonably resistant to heat. I can make it smoke a little bit or melt a little bit. Not too badly. They're not really made to take apart, and they sell them in a pack of 3 for $13, I think. So I guess they consider them disposable. Colleen at Fazio Amplifiers says that it is possible to get them apart. So maybe you can pry off the end with pliers and clean the solder out of them if need be. Each time you use it, you have to, of course, cock the piston or plunger and then hit the button, and it shoots back, creates a vacuum at the tip, and when you push it out, that little tip cleaner there that you see will push the solder plug back out. They seem to work okay. I've got another higher quality one somewhere around here. I don't even remember what brand. That's about the same size, which you can easily take apart, unscrew, change the O-ring, lube, whatever. And then, of course, there's the well-known solder pullet, big blue type, which you can hear I just cocked it and sucked. There's the pin that cleans it out. Any of these, if they're designed to come apart, of course, they will need solder bits and cleaned out of them, and probably a new O-ring at some point, some grease, all of which are available. You can buy a similar O-ring at the hardware store if you want to do the digging part. Okay. I got a circuit board pulled from an old tube type reel-to-reel here that we can just fart around with. That cable really is stiff. I really would like to put a silicone cable on that. Like I said, if I can get the iron apart, I can do it, because it's definitely possible to get the plug apart on the station itself. So I've got it set up for 700 degrees and can pretty easily, melt solder. If you're going to unsolder, you want to add a little fresh solder to it anyway, typically, because the flux in my Kester or other high quality solder, the rosin flux, will activate the solder and the flux in the solder and make it easier to desolder it. So here's pretty much got just about all of it in one swoop. Sometimes you have to do a second round. It's a little tougher to unsolder a tube socket. It may not take all the solder in one round. You'll see that I'm having little trouble softening this. Sorry, I went out of screen focus here. Okay, will this work? Got most of it, but it would probably need a little bit of solder braid, desoldering braid afterwards. This is the stuff that came with it, with the Schneider accessories kit. Seems all right. I'm not noticing a huge bit of difference when I was playing with it earlier between that and the tech spray here, although the tech spray is a little wider, which is often an advantage for larger connections, but either one seems to work reasonably well. I also picked up their accessory kit that includes the brass wool sponge, which I like better than the wet sponge technique. I've read that a wet sponge can cause stress microfractures from the quick cooling of the tip. You know, when you do this. With the brass wool, you just do that, and it works very well. I have a Heiko one, which is pretty much the same, but it might be nice to have one with a hood on it because it will collect little bits of solder. And I know from practice and experience that this will sometimes shoot bits of solder off the back end of it because it's springy. And you'll find them on, you know, your test equipment that's sitting behind your workplace area, splattered all over the bench and so on. The kit that they give you also comes with a tip tinner, which is a little different from my old tip tinner made by Multicore, which was a solder manufacturer. Here's the Schneider. It almost like wants to melt away and liquefy when I do this, and it sizzles. Okay, but obviously tip cleaner like that, you just quickly apply some solder to the tip and it's tinned and clean and shiny with solder. The old tip tinner that I have is like a solid plug of metal. I'm told that it's solder mixed with ammonium chloride, I think, which is a strong alkali. It kind of melts like solder does. It might be stronger, I don't know, or better than the Schneider tip cleaner, but they last years. I had one of these on my bench at work for over a decade, and it still pretty much looked like this. You really don't want to use that tip cleaner too much. If the Schneider is anything like this, it's strongly alkaline. It might be rough on the tips. You don't want to take the iron plating off prematurely. You just want to clean it enough that the tip is shiny. Keep some solder on it, you know, a little coating of solder at all times. Before you turn off the iron, put a little fresh solder on the tip, clean it, put a little fresh solder on it, put it in the holder and shut it off. And as long as there's always a little coating of solder on the tip, they should last you a long time. Like I said, you don't ever want to use anything really abrasive on them. You don't want to damage the iron plating, because once you get down to the base metal, which in the case of this higher quality tip is copper, the solder and flux will start dissolving away the copper, and hot copper oxidizes really quickly. You'll end up with pits and cracks and crevices and black gunk that won't come off, and you'll never be able to get a good proper tinning on the iron. Like I said, the one thing I really definitely don't like is the stiff cord here. Ideally, it should be silicone, and it would be nice to change it if I can get the iron apart and do it. But it seems to work reasonably well. They also give you in the one of the kits, the accessory kits, they have a solder flux paste. I don't know what it is. It may be formulated for lead-free soldering rather than leaded solder. I prefer lead tin solder. The joints are much higher quality. They hold up better under extremes of not just heat, but cold. I mean, it does sort of seem to work. You know, if I wipe it, the tip gets shiny. But it's not the same as my ancient Kester rosin paste. This stuff is rosin crystals in a petroleum jelly base. It actually says on the bottom that it's rosin flux. Okay. This stuff I don't know what it's made of. If you use the ancient Kester flux, it will smell like pine trees. You can tell it's a pine resin product. And even though it's crystalline and old, it just seems to work fine. You can use a little extra on your connections if you need to for cleaning. Handy on soldering chassis and so on, so forth. Or a little bit extra on a circuit board or other connection. But if you're using good solder that has, a flux core, and you're keeping your tip clean, and it's a well-made iron that has good temperature control, enough thermal mass to the tip, and enough conductivity from the tip, because it should be made of a good metal like copper, you probably won't need to use external flux very often, but it may be handy to have. You can buy liquid fluxes that are basically rosin dissolved in alcohol, but some of the ones I've seen, even though they're sold as being good for electronics and electrical, will then say on the bottle that they're not for electrical work. So there's a lot of bottling and rebranding of crap flux. Don't buy your stuff from China. All right, don't buy solder, flux, solder braid, any of that stuff directly from China. You will probably be disappointed. Buy it from a proper US-based distributor who specializes in this type of thing. Now I'm going to show you the inside of this machine very quickly, and then I will show you another brand name unit from a zombie brand you should never ever buy. Here's the inside of the Schneider unit, and the one thing that was wrong with it when I bought it was something was rattling inside. So I opened it up to take a look, and I found that the clamp that should be holding the cord right here, little piece of plastic strapping, was broken, and the post that the screw goes into to screw it down was also broken. So I just brought the cable a little farther inside of it and looped it around this post, put a couple of cable ties so that it can't pull out, and it's good enough. It would be, I could rig a better clamp, I'm sure, but it would be kind of tricky. But it's good enough. It will do for what we have to do. Now, let me put this out of the way. Also, it has a 1 amp 5 by 20 millimeter, I guess, a little miniature F-type fuse, they used to call them in here. It appeared to be a regular fast blow 1 amp fuse. So, and it's a miniature fuse, so it would be good to have those just in case you blow something and have to open it up. The inside of the unit actually has a fairly decent looking circuit board. Okay. There's the connections for the iron, for the connector for the iron. And it's a proper temperature controlling board. I don't know how accurate. I don't have a thermal, temperature measuring thermometer or one of those little infrared things. But it seems to work well enough. Now let's push this out of the way, and I will show you, before we wrap it up, what you should never buy. This is a Weller. Weller has been through a few other hands. They were owned, last I remember, by Cooper Tools. I don't know if that's still the case. Probably says on the bottom. It's got a basic iron that plugs into the wall socket. There is no advantage to using the station because the only thing that this temperature setting does is allow you to turn the iron down. It's a 40-watt iron that's supplied. You can turn it down and make it into like a 20 or 30-watt iron. Whoop-de-doo. If you want it a little hotter because you're soldering something with some thermal mass to it, you can't turn it up. The only thing you could do is buy a higher wattage iron than the 40-watt iron that's supplied SPG 40, it's 40 watt. You could buy a 60 watt or an 80 watt iron or something bigger, plug it in there and maybe turn it down temperature wise if you needed. But there's no thermal regulation. There's nothing that senses temperature, nothing to provide feedback to, drop to increase the temperature to the tip as you actually touch it to something you're soldering, and the tip cools slightly. And here's the connection on the side. It's just a regular wall socket type plug. Theoretically, you could put up to a 300 watt maximum soldering iron in here. I don't know. I don't know if I trust that. But the circuit inside, I had taken a look at it, and it's basically a light dimmer. It's got an electronic light dimmer on it. So you could use it as a light dimmer, or you maybe buy or if you already have a larger iron for soldering grounds to a chassis or something like that, to heavy steel, fine. And you could turn it down a little bit and maybe use it for some heavy electronics work. Light work, don't know. I wouldn't bet on it. But this thing is like $65 for these two pieces from a brand name that everybody thinks they should be able to know and trust. I would easily buy the Schneider unit for $20 less and just upgrade to some better quality tips. And like I said, you can buy some, accessories. The brass wool is good. I kind of prefer it over the sponge, and it works very well. The 3-pack of these is likely to be handy. Their version of solder braid seems to be okay, but if you're going to do a lot of circuit board work on delicate connections, I would strongly suggest that you buy, a spool of Chemwick, Chemtronics, or Tech Spray, or some other, better known brand, American brand. I have not tried their solder. I don't know if their solder is any good. I'm still using old rolls of Kester. This stuff actually has a couple percent silver in it. It's 62, 36, and 2% silver. Great stuff. And again, also, I don't know about their flux. It could be, more corrosive, aggressive flux for really designed for lead-free soldering, which I don't like, don't use, and don't recommend, especially to hobbyists, because it's much higher temperature soldering. It's hard to get good connections for if you're a newbie with lead-free solder, and you really have to remove all traces of lead-free type fluxes because they're more aggressive and corrosive than rosin flux, which is relatively inert, and that's what they use inside your multi-core lead solder is rosin. Jury is out on their tip cleaner. Like I said, I use the old one I have typically, and you don't need it very much if you keep the tip clean. Only when it really won't respond to like the brass sponge and a fresh coat of solder do you really need to use one of these. So that's about it. I hope this was helpful. And if you got any questions, comments, so on and so forth, let me know.